resemblance. This is so much fun. I did a term paper on this, and the distinguishable is separable principle. And usually what I'll do is look around the classroom and find someone wearing hot pink, and there's hot pink over there, and I'll ask, how is it possible for pink to be there and there at the same time? What makes pink pink? Isn't it exactly the same? It's the same color. Well, so there's pink and there's pink. That means that pink is in two places at once. So how can anything be in two places at once, right? It can't. But we usually go down a level and say, oh, it's not really that pink is in two places at once. There's particles in that object that's similar to the particles in that object, and that's what gives us the impression that the color is the same. So let me get this straight. There's particles there that are the same as those particles, and that's why I see pink in both places? Yes. Well, then you have the exact same particles in two places. Oh, no, that's not. Well, it's not that the particles are exactly the same. They're similar. Okay, well, if they're similar, what makes them similar? Well, some of the particles are exactly the same. Or the arrangement's exactly the same, right? Then I've got, wait a minute, what you've just done is you linguistically have gone down another level, but you haven't actually solved the problem of how we managed to see the exact same thing in two places.
This is where Mr. Gumby would say, my brain hurts.
Well, yeah, and I'm just hitting you with this one right after another one and so on. So in a short hour and 15 minutes, we're looking at all these problems. I, on the other hand, had like a whole semester to puzzle these out and so on. And, go to my room and sit there and read books. And, hey, wait a minute. No, that doesn't work. No, that doesn't. So you find yourself going through all these levels and you realize, oh, there's got to be a solution to this. No, there isn't. If anything, we could, still argue that, well, wait a minute, what's giving me the sense that the same perception, pink, is in two places at once, is that my receptors are responding to the light in exactly the same way. But you still find out, well, but that must be the same light in order for that same effect to happen. It doesn't go away. There's no magical level at which we can reach where suddenly the distinguishable, separable problem is resolved. It's just like the problem with mathematics and motion. If I accept the basic axioms of math, motion seems impossible, and we can't resolve that either, right?
It just goes on to infinity.
Exactly. And essentially what we might say is that the problem is that our conceptual schemas for explaining all of this fail us, because none of them are absolutely successful in doing everything. They're not successful in being accurate to kind of some map of correspondence to the world. There's all sorts of things going on in the world that we don't think of.
Yeah, it's like, even though I hate math, it's the only explanation I can think of. But like when they say plot a line, they actually say that the line's infinite because it can go for that point to that point for an infinite amount.
That's why you draw the arrows on them.
Yeah.
It means to keep on going.
It's just like, and that's the part I hate about math. I'm like, wait, so
Enjoy math. It's like the Marines when they talk about, embrace the suck. Because you think it's going to suck regardless, but if you enjoy it, you'll be okay. It'll work better for you, right? So you're out there in the rain and so on and so on. And enjoy it. So I hate math. No, just change your mind. Enjoy math, and now you'll see it'll work out much better for you. That's all in association of ideas. Again, has the same problem for us. How do we know that things can be grouped together? All cups, are cups. All tables are tables. That's something that we've literally experienced before. Okay. So,
That's mathematical in its own regard.
let me talk about this briefly too, because this is an important point.